So what's going on with freshwater eutrophication and phosphorus, and how does it challenge the water environment? We're going to take a look here at this report from UK government. So first we have to define what is eutrophication. This is when there's too much nutrients in rivers, lakes, reservoirs, estuaries, or the sea, causing excessive growth of algae and plants. This adversely affects the quality of the water and our uses of it, as well as damaging the local ecology. And which nutrients are involved in this? Well, we have the phosphorus, nitrogen are the main nutrients involved in eutrophication, with phosphorus the main cause of eutrophication in fresh waters. Standard for phosphorus in UK rivers and lakes were introduced under the Water Framework Directive and regulations hereafter to the WFDR in 2009, and the river standards were updated in 2015. And while these aim to prevent and limit eutrophication. Now, nitrogen can contribute to freshwater eutrophication in some situations, particularly in lakes, and under the nitrate pollution prevention regulations, some affected lakes in England already have controlled measures to reduce nitrogen pollution caused by agriculture. And the UK Technical Advisory Group, or UK TAG, for the WFDR consulted in 2019, proposed on L standards for alongside use of P standards for eutrophication control. And these are now being introduced for the 2002 river basin management plans. And in saline waters, nitrogen is usually the key nutrient involved in eutrophication, but phosphorus may also be important in some estuary situations. In considering the ways of controlling phosphorus pollution, particularly from agriculture, we should also consider current and future measurements for tackling nitrogen pollution. What are some of the problems? For 2 decades, the Environmental Agency and other interested groups have identified the risks and impacts of freshwater eutrophication in England as a significant concern. And eutrophication increases the cost of drinking water, abstraction, and treatment, and adversely affects angling, water sports, and other recreational activities, and causes the loss of sensitive plants, animals in rivers and lakes. P concentrations in our rivers increased significantly between 1950 and 1980s due to the introduction of P-based detergents, population growth, and the growing use of artificial P fertilizers. And despite good progress in tackling phosphorus pollution since 1990, 55% of asserted water river bodies and 75% of assessed lake water bodies in England fail the current WFDR phosphorus standards for good ecological status, which aim to prevent eutrophication. And in fact, phosphorus is the most common cause of water quality failures under the WFDR in England, the #1 reason for water bodies not achieving good ecological status. And some waters are formally designated as affected by freshwater eutrophication. These are waters formally identified by DFRA as the Welsh Government, or sensitive areas or polluted water areas affected by eutrophication under the urban wastewater treatment or nitrate pollution prevention regulations. And the ecological risks from phosphorus in rivers and lakes have been designated for conservation. Interests are also a concern, as nutrients are one of the main reasons for the site not achieving favorable condition. And according to the manage risks and impacts of eutrophication is an important aspect of the government's 25-year environmental aim to achieve clean and plentiful water and thriving plants and wildlife. And some of the main sources are the lake or sewage effluent, primarily from water industry and treatment works, losses from agricultural land, food waste, drink additives, P-dosing of water, and contribution to sewage P loadings, septic tanks, packaged sewage treatment plants. Small sources nationally can be important, but particularly in the headwaters of catchments as well. So this is some good information on eutrophication, where it comes from, and why this is a problem. And as we can see, it's too much phosphorus and nitrogen. How do you know if that's going on in your water? The only way to properly know is to test your water for high levels of these various nutrients.